Here are some more home building education series videos. Let's go ahead and get started with our first one. Here is another problem that you should be aware of if you are going to be adding a porch to an existing home with a truss roof, with a situation where you will have 2x4 top cords and will be using a larger rafter. And if you cut a regular seat cut, the rafter is going to be sitting a little too high to blend in with the existing roof. And I realize this isn't going to happen that often. But what about when somebody installs a porch beam even with the top of the framing plates, because they haven't taken enough time to do a little planning, and they end up destroying the bottom of the roof rafter to make it fit. And I can't tell you how many times I come across a situation like this, where this section of the roof rafter is not structurally supported. And in reality, you just took a 2x10 and turned it into a 2x4 or a 2x6, when all you needed to do was lower the porch beam, unless you're not going to have enough headroom. Headroom clearance here is going to be a problem if you have 8-foot walls on the inside of the house. And if that's going to be the case, you might need to install 4x8s or 6x6s for your roof rafters, or even roof trusses, or modify the design of the porch to create something that is going to be accepted by your local building department. And I realize I made this sound a little easier than it's going to be on some of the projects. So use it if it works. If not, feel free to email me some pictures of your situation and I will try and take a look at it. Here's a question that I received a long time ago, and I'm sure it's not going to do the individual any good now, but keep in mind I can't answer all of the questions in a timely manner that I get, but this could help someone in the future. They were wondering, they had a situation like this, and they wanted to put a set of stairs in between. And they didn't want to deal with this. I know this is a big problem. I see it a lot. And I understand, you got to keep in mind, if you need this for some type of handicap or disabled access, you need this. This is going to be a ramp. It's going to come up. You're not going to be able to do this, not going to be able to use this idea. But if you're building something like this on another property, maybe even your own property, then this just might help. And there's the solution. You don't want to have the angled steps or the risers because they're dangerous. And I drew this. I didn't draw it to make it look awesome here. I just kind of drew it to where it could make sense. You would need to cut a section of the existing concrete out at the top and the bottom. You need to cut a couple of lines so that you could build this. And if you notice, this one here is working out. I got this one coming up to here, and then this one comes over to here, but the top, it's not going to be the same. This corner is going to line up, but this one here is going to run a little bit farther past the edge here to work out with the ramp. So not too difficult. You're going to come up, you'll have a landing, another step, and then you can work your way up the ramp. The riser height can vary. They don't have to be the same. You know, if you have a situation where you might want to move the riser back a little farther, knock yourself out. The design idea, though, is quite simple, again, if you don't need some type of a handicap or disabilities ramp. So you just simply cut the walkway here, reform your new step. This would be level. And again, you could always have something like this sloping in one direction also. You know, if this is level, then it might, you could end up with a puddle here. This could actually continue to slope down in this direction. Now, you do need to keep in mind 4 inches is usually the minimum riser height. If this is the case, then you're going to have to come back farther. So don't be discouraged. You know, if you have a bigger ramp up here, you know, if you have 3.5 inches, all you need to do is bring this step down a little bit further until you have at least the minimum desired riser height for your area. So here we would have the same riser height here. We're not trying to step on top of here and creating a trip hazard. In this video, I will provide you with an example of how you can build a floor cantilever on the side of the building where the joists are going to be running perpendicular. So for a cantilever on this side, we can simply extend the joist or attach new joists to the ones that are running parallel. However, we won't be able to do that if we want to put a cantilever on this side. And to do that, all we need to do is something like this. We can install our cantilever joist perpendicular to the floor joist or at a 90-degree angle and simply add a doubler here, and a doubler over here. And as far as the cantilever span, you might need to check with your local building department or engineers because some of them might have a maximum of 1/3 of the distance or length of the cantilever joist, while others might have a maximum distance of 1/4. An example of that would be if this was a 1/3 cantilever and the length of this joist right here was 48 inches long, then we could cantilever out 16 inches or 1/3 of the length. However, if it was 1/4 and we had 48 inches or 4 feet, then the cantilever could only extend out 12 inches. So it wouldn't be a bad idea to check with local contractors, building authorities, or engineers before building or adding something like this to an existing home. And of course, we will use hangers to attach all of the joists that will require them. And of course, we will have a doubler, a double stud underneath all of our double floor joists. And I understand if you're remodeling something like this and it's a small cantilever, you might get away without putting them in there. However, as someone who tries to be a responsible educator in the construction field, I gotta point that out. Most engineers are going to require double wall framing studs underneath your double joist, and that will include the double joist you're going to be attaching the cantilever to. So another set of double studs, or even a post. You might want to put a post there, or your engineer might require you to put a post there. And the rim joist can be attached by using 16D nails. And if you have 2x10 or 2x12, you might want to use 4 nails per joist connection. In the next video here, I'm going to go ahead and do some narration instead of the music because I think a lot of stuff's already been covered about the fence. But let's go ahead and take a look at one picture here at a time. If you remember, this is the concrete footing where the metal is that is protecting the wood from the other side because my neighbor put a lot of dirt back there and raised that area and it's putting a lot of pressure on the fence also. And of course, any water that would come from that side down the hill would come out in this area. We're going to have to keep that in mind. The fence, I got one last section to build. And then, of course, where the metal was, I thought I would reinforce it by putting some boards into the ground. And I'm not using pressure-treated lumber here. I don't know how long this is going to last. If I have a board that rots out, I can simply replace it, no biggie. And then this is kind of pushing it up tight against here, tight against the metal so that I can backfill everything. A view from the other side, our little cat there. He is no longer with us. He was a little too active, ran out in the street one day. Now, I need to add some concrete to this post. And you'll see that here in a little bit, but that's why we have some of the soil pulled away from the fence. Everything's looking good. Here are some of the old post footings that are pulled out of the ground. The last section of the fence again that needs to be built, and I'll have a video on that, and I think I have 2 more videos and that will be the end of that. And I have my string here tied to the post so I can figure out where I want to put the footing, connected to the other side where the new fence is going to intersect into the old fences there back in the corner. So here we can figure out you're using the string line. You can simply measure over to find the center or the desired location of your footing. Threw some gravel in the bottom. Set the post, brace it off, And of course I have the top rails installed. Everything is ready for the concrete. Start pouring the concrete. Again, we're using our cardboard forms. They seem to work well for situations like this, and I would highly recommend using something like this if you're going to build a fence. And of course, this is the post that needs to be raised. I'm just going to raise the concrete, so there will be a cold joint in here where water can actually seep into here and be a problem, but I don't think it's going to be a problem, because the soil here is on the side of a hill. So if this was like in a valley instead of at the edge of a hill where water can simply work its way out of the soil on the side of the hill, doesn't really have a place to get trapped. So I don't think I'm going to be too worried about that. But again, if I just leave it like this and then backfill it with soil, then it's going to rot out even faster. So I'm just kind of adding a little protection there, or at least something that is going to be better than nothing, kind of a deal. And again, we're using our cardboard. Simply going to backfill the soil around it as we're filling it with concrete. And you can see where the concrete is starting to be placed there. And of course our other footing where the last section of the fence needs to be built. Now let's go to the other side of the fence here. You can see where I have the concrete kind of coming up to the metal. You're going to have to, if you're going to do something like this, you're going to have something. If you leave the concrete below the metal, then you're going to have all of the soil from up here kind of getting in between that area also. I just went ahead and threw a little more concrete in this area because it's going to get filled with soil, I'm sure. I won't have any control once I'm done with the fence here. My neighbor can come in and fill the area. And he's not somebody who does a lot with this section of the backyard. So as long as he's not watering the fence here, watering the stuff, this thing could last a lot longer than even I'm expecting. But again, this is kind of a test using that metal. I don't know how well it's going to do there. It's not a real thick metal, even though it's galvanized. So view of the fence again, everything looking nice and straight. Cardboard form on the other side. Just gonna kind of pick up the pace here. I did have a couple of bad boards like this. I went ahead and used them anyway. When I went down to pick up some of the lumber, my neighbor just grabbed a bunch and threw it in there, so I figured, what the heck, and it's a fence, I'm not gonna worry about it. So I'm pretty sure I used that stuff down on the bottom also, didn't use it on the top. And of course the cardboard form removed, nailed in the bottom rails, everything's looking good. And I do have a video on installing this last section, giving you an idea of what I was measuring there. 16 inches. That's probably the top of the fencing. I don't have my string set up there yet, but I was using my string. If you watch some of the earlier videos, I was using my string and then measuring down to get the top of the footing heights so that the bottom of my fencing boards would actually sit on top. I wouldn't have to notch that section. And again, there are the 6-foot boards. Definitely a time-saving method and something that's going to make your fence look a little nicer. Also, again, 16 inches. There it is from the top, 14.5 inches. And there's our string set. Installing the one side. And then at the corner, I didn't bother ripping a piece of fencing down. I just nailed another one tight against here and screwed it in the back. Again, if this was going to be something that people were going to be looking at every day, then I could have ripped the last piece in there. But this is behind my neighbor's tree. Like you can see it here. There's a tree here. And this should give you a better idea of what I'm talking about here. Fence on the other side. Just kind of running through everything. Backfilled the soil here. to kind of give you an idea too of what it's going to look like. I'm not saying that this is going to be the finished project, part of it, but I kind of put some dirt here so that I could create a little valley here for the water to go down. But again, once my neighbor gets back there, he could change everything. And you could see here where any water that gets in here is going to be coming down here pretty fast once it gets into this area. But as I'm making this video, it is December 7th, a year later. And I'm finishing up this series of videos. Some people didn't take much of an interest in it, so wasn't really worried about it. But I wanted to finish it. And we haven't had any heavy rains yet, so I don't have any, I can't compare it, I can't provide you with any info on that. And I will put other videos in here as, take a look at this one here. That one's going to have to go up against a wood post. If you do have any bent boards like this, I actually had a couple when I was working on it, building the fence. And if you want to just say you can replace them, or take and put this one here up against wherever the wood post is. That's a pretty good one. You could just put it right here. You would use it right here. And, you could always remove this one and replace. You could exchange them also. Just something else to think about. Installing the other part of the fence. And this is going to bring us to the end of this slideshow here. Fence is completed. In this video, I am going to provide you with a few simple yet effective methods that an architect or building designer might use to design one of these crazy decks that you're trying to figure out how in the heck they're designed. How do they come up with these ideas? And a lot of times it's just as simple as using a different size square and a different sized circle. And again, that's all I'm going to focus on in this video. I might make another video. If you like this, you want to see more of it, hit the thumbs up button, leave a comment, let me know, and I'll get into a few different shapes. But the principles are the same. You're simply going to take a few of these squares and then move them around until you get kind of a design that you like. Now, the measurements on these to scale are 4 foot taller or 4 foot wider than the others. So here we have an 8-foot circle, 8 foot long square, then we're going to add 4 feet to that, 12 foot diameter, 16 foot diameter, 16 foot, 20 foot, and 20 foot diameter. The first deck I'm going to build, I'm just simply going to grab these squares and put them in order like this. And you could see here where you could have a deck with 2 steps going up to a landing here or up to a deck. And that would end up looking something like this. 12 foot by 12 foot deck on the top, 4 foot steps going down in each direction. If I wanted to make the steps smaller, then I would simply make these squares a little smaller also. So 12 foot square on top, 13 foot square here, 14 foot square here. Now these would give me 12-inch or 1 foot wide steps. If I wanted to make the steps wider, I would just simply adjust accordingly. So if I wanted to have a step that was 2 foot, then I would have a 12 foot square on the top, 14 foot square on the bottom, 16 foot square underneath that one. And of course you could do the same thing with these circles. Center them in. And you would end up with something like this. Next up on the list, we will take a square and a circle. We're going to take the same sized circle. And I'm just going to kind of slide it in here to where you can see where we have a deck that would be square with a rounded edge, providing us with something like this, a shape like this. And again, I know a lot of people, they're like, how in the heck do I get something like this? And it's not that difficult. you can take a square and then come to the center point in the square and then take a measurement. 12 foot, we're going to have 6 foot, and we're just simply going to draw a curved shape around it. Now, what if I want to have a deck with round steps coming off of it? I'm going to do the same thing. I'm going to kind of snap this in and then grab another one. And then our deck is going to be up here. We're going to have, this will be our first step here. So I'm going to go ahead and get rid of our lines here around it. So here we would have a deck that would come all the way out here with a curved step. And that would end up looking something like this. Now here's another common design that I see. It would just simply be a square with a circle. And if you notice, I drew center points in the circle so I could make this a little easier. So here I could have something where I have a square and then a round deck coming off. Now if I wanted to put my little stairs in here, I could simply do it like this. So let's go ahead and take a look at our deck without all of the lines in here. So here we'd have a flat surface coming to a step. And of course, this is what it would end up looking like. So a square deck here with a kind of a pop-out circle and then a step going around. And of course, you could always have a step coming around like this and then have it come over here. You just simply add a step here to make it work out to where you would have a different type of design. And by now you should be getting a pretty good idea what I'm doing here and how you can just kind of grab a couple of circles, some squares, and other geometric shapes and put them together to form a variety of different decks. And I know the main reason why I did this video here was to provide do-it-yourselfers with a general understanding of just exactly how simple some of these designs can be created by just a few geometric shapes and even basic geometric shapes like a square and a circle. So that's it for the video. I am going to do a couple of more videos about deck design, and if I do, I'll put a playlist together, put a link to it in the video description area or in the video here somewhere. Don't forget, you can always visit the website, and I do have sections of the website broken down. So for example, for decks, you can go to the outdoor tab and then click on decks from there. And then you can also go to the design tab and the repair tab and find decks and get more information about designing decks in the design area, building decks in the outdoor, on the outdoor tab, and then of course repairs for decks in the repair section of the website. Here's a quick tip for anyone who is looking for extreme accuracy when building a set of stairs, and that will be to avoid using this part of the tape measure to create an accurate measurement. Instead, add an inch to the measurement. So I was trying to get a 5.5 inch measurement, move it back an inch, go to 6.5 inches, and then go to the 1 inch mark on the tape measure to make your mark. And you can see here where we have 5.5 inches. However, if I go back here, you can see where the tape measure is a little bit off. It's almost a 1/16 of an inch off if I'm holding the edge of the tape, which is often loose, and loose for a couple of reasons. I'm not going to go into the details on that, the reasons why the edge of the tape measure or the tongue is going to be off a little bit. So again, just simply add an inch. You can add 1/4 of an inch or a 1/2 inch, but it's usually easier for me to add an inch and then go to the 1 inch mark on the tape measure. And I'll even use this method here when checking my treads and risers when setting up my framing square or for other measurements that I need to be within a 32nd of an inch of. Here's a tip I'd like to share with you, and I actually got it from a viewer. They were watching a video, one of the videos I did on doweling, I believe, and they had brought up a good point that I'd share it with you. Now, here's an example of dowels that get drilled into a concrete foundation. You can see the dowel here and then a piece of rebar tying to it. Let's take a look at a few more pictures. Here they are connected going all the way across. We have a house here and a detached garage. We went ahead and built a room addition in here. And here's the dowel, a piece of rebar, 1/2 inch I would imagine. You drill a hole into the concrete, put some epoxy in, slide one of these babies in, and you have a dowel, a ready connection for something that's going to give you some structural strength for a concrete slab, mainly like a room addition. This wouldn't be something you would see in new construction, hopefully. Here it is again. Here's what it would look like finished. Here we have the dowels going across. Now, what I'd like to talk about is a different way to do it. Now, here is the way that I had in the pictures we just looked at. We had a dowel going into the concrete, a piece of rebar tied to it, and a piece of rebar going into the other foundation. So we had a continuous piece of rebar here and 2 separate dowels. Now this right here would provide us with a better method. I would imagine would provide us with a better connection. This would be taking a full length piece of rebar and then doweling it into the concrete slab and then attaching it to a dowel that is installed into the other concrete slab. It would basically eliminate one of these connections. Now, this is a great idea, and I've actually done it before, but I've had some problems. First thing I'd like to point out is that when you install a small dowel, you usually have a lot more control over it. You knock it in, you have the dowel in, and it usually isn't going to move. And remember, this stuff cannot move. So if you use a long piece of rebar for something like this, it wouldn't be a bad idea to put some 2x4s or something underneath these areas, something to lay the rebar on while the epoxy is setting. You will need to set the rebar in place and it cannot move. Problem I ran into when I did this once was that I kept on, I would put the rebar in and it sagged down. I didn't have boards supporting it. And I kicked a couple of them a few times. I mean, if you could just imagine you're trying to walk over this stuff, while you're putting the other epoxying the rest of the rebar in, and it would move. So that's not a good thing. So be careful if you are going to use this method right here. And it is actually a method I would use again, just now that I know what not to do, kind of a thing. What we are looking at here is a perfectly straight wall with no imperfections at all. If we sight down it, put a level on it, straight edge, it is going to be perfectly flat in both horizontal and vertical directions. Now here's a wall that isn't very straight. It's got some nice bowed studs in it. But for illustration purposes, I went ahead and did this. Obviously, you wouldn't use a wall stud like this, but I wanted to make sure you could see what the wall was going to look like. Now, the wall is going to, if you were to put a straight edge on a wall like this, it's going to be straight in this direction. If you went vertically, it's not going to be straight. Now, the reason why I provided you with this example here was just to give you an idea of what the bowed studs look like. And this is what it would look like if all of the bowed studs were going in the same direction. All of the bows in the stud were facing outward in the same direction. Now here's the secret to the reason why I made the video, and that was to point out the problems you're going to have if you don't crown all of your studs in the same direction. If you were going to frame a wall on the ground and then stand it up, you would simply need to sight all of the wall studs, look down the length of the stud and see where the bow or the crown was. And obviously, if there was no bow, if the stud was nice and straight, you just simply place it. You could place it in either direction. And then if you have one that's got a slight crown or a slight bow on it, then put it face down or face up, and then run all of them in that direction. If you are stick framing, where you have the bottom plate attached to the building and you're going to put each stud in individually, then simply sight each stud, look at it, and put the crown in the same direction this way. So if you're going to frame either way on the ground or stick framing like this, then you just need to make sure that the studs are going the same direction. Trust me, this is a lifesaver for when you go to straighten all of the walls at the end, and it really does make a big difference. I did it on a room addition. I was taking my time with. Obviously, if you're in a hurry and you're not, you're the framer and you're not going to be doing the wall straightening, you don't care. But if you're the builder and you're going to be paying for all of this, then it might make a big difference. And the room addition I did really made a big difference, and the walls really turned out great. Here are a few ways you can frame a corner window. We have two headers here, two sills, and they are intersecting into a king stud. And this method here would be used if you needed a little more room on the outside or the inside. Here we have a king stud and then a full-length trimmer over here, and then a king stud. It's the window sill, subsill, and the cripples or jack studs, and headers. Here we can see how the bottom is laid out. Again, two studs away. This right here is used. Most common method for using, or reason for using this type of construction method would be if you had window trim. So for example, if you were going to use wood windows and then put a 2-inch piece of trim around the window, kind of give it a picture frame look, then you would need to use something like this. You can't take and stick the windows all the way in the corner. You're going to need some room. And this method right here would be great for that. And you might even need to move it 1.5 inches further, depending upon the thickness of the window trim. In this method here, we are using a 4x4 in the corner and a full-length trimmer on each side. This would keep us 1.5 inches away from the corner. And again, this method could be used if you were going to use a certain type of wood trim, a little smaller wood trim. Would work fine for windows that, something like a vinyl window or aluminum window. I say aluminum windows, I don't even know if they make them anymore. This is 2016, and who knows? I don't know when the last time was I seen an aluminum window. This would be a window with a flange and maybe a 1-inch to 2-inch, even a 3-inch, depending upon the thickness of the window and the thickness of your wall framing. It would be something that would stop in the and that would not need to be trimmed out with wood. Here's a 4x4 in the corner, and this is probably the most common method used for framing corner windows. You would have no trimmer in the corner to support the headers, because the headers would be sitting on top of the 4x4. They are mitered with a 45-degree angle. I'll show you a little bit more of that here in a few minutes. 4x4 supporting the window header, a 2x4 full-length trimmer supporting the header on this side. Here's how the bottom section would be framed so that you have plenty of backing for drywall. Upper corner or upper inside corner, again sitting on the 4x4, everything dies into the corner. Here you would have a nice line coming out here, and then of course you would drywall this or trim it out with wood, however you were going to finish it. Another view here just to show you where it's supporting the 4x4. The 4x4 post is supporting the headers. Last but not least, take a look at what the mitered header would look like. You would have a header, a 4x6, 4x8 window header, and you would miter the corner with a 45-degree angle, depending upon what corner you're using. A standard corner of a home is 90 degrees. If this was going to be a different, you could use this same method for another corner type of window, but you would just need to change the angle of the header you were going to use if the wall was not intersecting at a 90-degree angle. Hope that makes sense. Here's the last example I could come up with. If you have another example or another idea, feel free to email them to me, and I will see if I can attach a link to them at the end of the video or make another video. Now, this one actually uses hangers. These are inverted hangers that will attach to the 4x4. Now, something else I'd like to point out here is in this example, we are using a floating trimmer where the trimmer stops at the subsill and doesn't go all the way to the ground. I just wanted to give you an idea of the different trimmers that you could use. So here you can see right here, we have the trimmer sitting on top of the subsill, and here it is going all the way down to the ground. Two hangers in the corner. Just kind of wanted to pan back here and give you another idea with the trimmers, how they're supporting the header. Header supported by a full-length trimmer, a header that is supported by a floating trimmer. What's the difference? A lot of people I worked with like to use the floating trimmer so that they could move the bottom just in case they had to. And that's a good enough reason for me right there. I like this method here. If you are building homes nice and plumb, they're plumb and level, you're not going to have everything's nice and square. This method right here would provide you with a little more support. But as you can also see, it's going to require another cripple, let's say. You know, here you can see that we only have 2. Over here we have 3. So it's going to require a little more wood to do it this way also. Take a look at the hangers. Hangers attached to the post. Nail in there, and this is an inverted hanger. You can usually find it as a Simpson HU. Again, that's an inverted hanger. The flanges are not on the outside, they are on the inside. Now, here's one of the reasons why I don't like using this method. And I've seen, sometimes I've had to deal with it. Structural engineers put it in there, but the hangers usually create problems for the drywaller and whoever's going to be putting the exterior finish on, because they're usually a little bit bigger. And here you can see it's kind of sticking out here. Let's just say it's an 1/8 of an inch. I mean, a 1/16 of an inch. That's fine. That probably wouldn't be too bad, but it's going to create a little bump in the drywall, and this usually isn't a good thing all the time. So let's just see if I can kind of go out here. Another problem it's going to have is for nailing the drywall in these corners. So you could imagine when you put the drywall here, this will be the furthest you're going to be able to put a screw or a nail, and the same thing here. And I'm just going to see if I can pan around to the outside. This wouldn't be as big of a problem on the outside because you're going to be nailing over here. So, but again, the reason why I don't like using these is because they usually create a bump or a dip. And if you don't nail the hanger on correctly, then you could actually have problems. It could be sticking out even further. And of course, I've nailed these things on before where I couldn't get the beam in or the header in because I had nailed them too close together. So not a big fan of this method. I would go with the method before this one where you have where you use the mitered headers. In this video, I'm going to show you how to support a vaulted roof for small load-bearing exterior wall repairs. Small would be maybe 4 foot or less. It could stretch up to 6 feet, but you might need additional support for larger wall repairs, and I'll try to make a video on that in the future also. Let's go ahead and take a look at kind of where the damage would be for a repair like this. If you have a framed floor, a wood framed floor, and you have some damage to your joists, maybe to the plywood, where you would need to support the wall because you'd be removing structural wall framing studs or posts, something like that, then this method might work for you. Let's just go ahead and kind of zoom around, get an idea of what we're looking at. I removed another section or the other section of the house so that we could have a better idea what we're looking at and what type of support system we're going to use. Here's the first method and probably the most common that I have used. This would be to build a supporting wall, install some type of a framing plate. You might want to level out the dirt. And something like this, you can always use like a 4x12 or a 4x10 if you're looking for a little more support or stability. But you could always do this by you just kind of flattening the dirt out or using blocks, something to give you some extra support. Now, where you put the wall, how far away from the exterior wall will depend upon the repair. You might need to give yourself a foot. You might need to move it a little farther this way. The closer to the wall, the less the distance that the rafters will have to span to carry the load. Remember that some roof rafters might be designed for a 12-foot span, and if you start to bring this wall into a 13 or 14 feet span, then you might end up, you could weaken the structure. I doubt if it would fail, but it would be definitely something to consider. So I like to keep these walls as close as I can, depending upon the type of repairs. If you got to knock the stucco off or something like that, you're not going to want these wall studs in your way, and might need to go to where you support the wall on the inside. This right here, I have two 2x4s. You can use 2x6, and one of them is going underneath the rafter, and the other one is next to the rafter. This way you can nail or screw the stud into the rafter. You can screw or nail the two studs together, and you can always use one wall stud if you want, and maybe put some type of a flat piece of building hardware on here where you can screw into it some type of a framing plate. You know, you can just find something like a flat A35 and screw it into each to make a nice connection. I mean, the last thing you want to do is nail this thing in or do something and have your wall exposed and have one of these things come apart. So a screw would be nice. Screws would be nice for something like that. You can always use supporting walls on the inside, and do not forget that if you are doing something like this on a concrete foundation, you probably won't have a problem. You can just put a 2x6 or 2x4, something like that on the bottom. But if it's a wood framed floor, you'd probably need to find out which way the ceiling or the floor joists go. If the floor joists go this way, perpendicular, I should say, to your framing plate or your temporary framing plate, then you're going to be fine. If they're running the same way, if the joists are running parallel to the wall, then you might need to create another type of support system, something where you would run a board, maybe something 6 foot this way, a 2x4 or a 2x10, something like that. And then you might space 1, 2, 3, 4 of them, and then run your board perpendicular to those. You're going to need some additional support somehow. And if you need more help on that, I will see if I can make a video, and I'll put a link in here if when I do. So you would just build a wall, screw it into the roof rafters. You're actually going to have to find the roof rafters. I'm assuming that you're not going to be ripping the drywall off to make this type of a repair. If you are going to remove the drywall, then you'd be able to attach the wall studs and the framing plate to the roof rafters directly. If you're not going to remove the drywall, you're not going to remove the insulation, then something like this probably would work just fine. Framing plate, again, you can always use a bigger plate, 2x10s, 4x10s, something like that. Same thing applies on the outside. And you might need to build 2 different walls. You might need to have one wall on one side of a wall, one wall on the other side. Another thing you might consider is building a partial wall on the outside. If you have something in the way, you could have plants in the way, something that you're not going to be able to, something that won't carry a lot of weight or support. You might have a deck in the front that isn't very strong. You can always build a partial wall in the front and then use a partial wall in the inside. And if you're looking for some extra support, you might have a tile roof. You might have a roof with a lot of weight on it somehow, some type of a heavy roof, larger framing members. Then you might want to build a wall on the inside and a wall on the outside to get some extra support. The main thing you're going to need to consider is to not build the wall, avoid building the wall in the way of the repair area. If you need to get to this area here and you have a wall up against it, it's going to be difficult to work on. So give a little bit of thought into this before you figure out where you want to locate the walls, and make sure that you're not putting them in your way and you won't be able to do any work, or put them in the way, you know. And again, these are all mistakes I've made. That's kind of why I'm sharing them with you. I've built walls like this, and then I couldn't open the door to get in and out of the house, and had to walk all the way to the back, go through the back of the house, because I'd blocked this area off like a numbskull. So little bit of wisdom there I'm sharing with you. Hope you don't make the same mistakes. And remember, these are just examples. These are not the only methods or the most effective, the best out there, and things change. If you have a better idea, feel free to leave it in the comment area, and maybe I can make a video out of it and attach a link to this one and share it with others as well. In this video, I want to talk about floor drain locations. Try to keep them out of high traffic areas. You can see right here there's a door. Anybody who comes out of this door is probably going to have a good chance over time of stepping on the drain. And if the drain isn't even with the surface, if it's down just a little bit, it could create a trip hazard. Now here's another drain. Now I'm going to go over in the video, give you an idea of how people travel. High traffic areas are areas where people are going to gravitate to as the easiest path of travel. For example, coming down this ramp and going down the stairway, you're probably going to be right up against the wall here, right around here, and then go down the stairs. You're not going to walk around here, come way out here, and then go down here. So this would be a high traffic area right here. This area here would be a high traffic area if you were going in this direction. Now I'm not suggesting that you locate all of the drains out of high traffic areas if you can't. I understand that there are going to be situations where the drain needs to be located to create or to make the job work as far as sloping the concrete in a certain direction. If you're up against four walls, you have a stairway here and a wall here, you would have to slope the concrete in one direction, and if you sloped it all the way to the wall, you might have problems. So I understand with something like this is actually a good location, and it might not be in a high traffic area. Even though it's in an area where people can step on it, it's not going to be in a high traffic area if people are walking in these directions. Now here's an example of a drain that you would want to keep out of the path. You have a sidewalk here and you're going to be walking towards the door. This is going to be the main path of travel. People aren't going to walk over here and go this way and then over here. They're not going to go here. They're going to be coming straight to the door. And this drain right here would definitely create a problem. You'd probably want to locate them off to the side. And you think about the high traffic area, it's going to be right here, coming off the sidewalk to here. It's also going to be coming off the sidewalk, going to the right or the left, coming out of the door, going to the right or the left also. You could always put the drains in the corners. This would be the ideal location because these are not going to be in traffic areas, especially if they're within a foot from the wall. Most people aren't going to walk in the space of 1 foot up against a building. This would actually be the perfect area for floor drains. Now, if you have a walkway going to another walkway, I drew this line in here to give you an idea of the high traffic area. This would be the main path of travel in this area. So it would be between the sidewalk here, between the sidewalk in this area here. And you would also have high traffic areas if people were going to the right or the left. And again, they're going to be gravitating towards the corners. You're not going to swing way out here most of the time and come down the center here. So you could actually put drains in the center of certain areas because they're not going to be high traffic areas, even though people can step on them. It's not going to be the main path of travel. Now, if you have a wall of some type, and this is what we were looking at in, I think, the second and the third pictures. If you have a wall of some type, the center might be the perfect location because you're going to be sloping it from the outside in, and this might be the only way you can install the drain or the best location. However, if you can put it in the corner, this would be the ideal spot. You think about someone's going to come around here on the sidewalk, come around here, and they could be walking in this area here. And again, I would imagine if it's within a foot from the wall, you're not going to have a problem with it in these areas. If you needed to bring the drain out a little bit, then you could actually have a problem. If you needed to bring the drain out about 2 feet, and this was an area where people were going to be walking and sitting on the planters or something like that, that could be a problem. It actually could be located in a high traffic area. But again, if it's located within a foot from the wall, I wouldn't consider that to be in an area because people aren't going to be walking that close to the wall. This video is a response to an email I received a while ago. Someone wanted to know how to cut the circular shaped board, how to lay it out and cut it. And it's quite simple, and I'm using a 2x6 here. Simply lay it on the ground, and I just put a screw in, and you can do this wherever. I put a screw in, or you can use a stake with a screw. You can do it a variety of different ways actually, but here is how I did it. Simply grab your tape measure, hook it over the screw, the edge of the screw, or a nail, and line it up if you need. I'm using 4 foot here for an example, 48 inches. I'm getting it lined up with the 48 inches, double checking, moving it over. After I have it where I want it, I can draw the line. Simply grab your pencil, follow the 48-inch mark, And you are done. Now I'm also going to provide you with a couple of pictures of what this would look like. Give you a close-up. Here we go. Hopefully you can see that. Here is the middle. Now you can use a jigsaw, a circular saw, or a bandsaw to cut something like this. I would recommend using a jigsaw if you're not familiar with using the other methods, and you can usually purchase a jigsaw for under $50 at most home improvement centers if you don't have one already. What we're looking at here is a common problem. I see it a lot. You will have a stair tread when you're using 2 or 3 pieces. Here it looks like they're using 2 2x6s. I've actually seen them use 3 2x4s before for a stair tread, or a 2x6 and a 2x4, 2x8 and a 2x4, but different pieces of lumber, 2 separate pieces for a stair tread. And one of them warps, and you end up with something like this. Now this looks like some nice wood. I hate to say it. I mean, this looks like some expensive wood here that they're using for the stairway. And if you are going to spend a little extra money, you're going to get some nice lumber, some teak, some oak, something like that. I don't know. This is an exterior stairway. You're going to use a hardwood or something, and you're looking for something that's going to give you a little more insurance. I think I just might have a tip that you might be able to use. Here's a stairway, and we got 3 stringers. Take a different look here. I got to throw some drama in here. Come on. So here's our double 2x6 treads as we seen in the previous picture. Flip the stairway over, and voila. What about putting a strap or some type of building hardware to tie the treads together? You wouldn't be able to see it if you were going to leave an open riser like the other stairway had. And remember, open risers aren't going to meet most building codes today. So check with your local building department. But a strap right here would definitely provide you with a little more insurance. And again, I'm not recommending you do this on every stairway. You don't need to use a strap. You could always use a flat, I believe they're LP T4s or A35s. You could always put a couple in. But this is something you could do. You just, when you're installing the stairway, your treads, you flip the treads over, have them upside down, put your straps on, and then turn it over and install the tread through the, let's see, go back here. You flip them over, and then after you've connected them together, flip it back over and attach it to the stringer. So this isn't something that would be extraordinarily difficult. It's not something you would need to do from the bottom of the stairway while you're assembling it. But this could always be something you could do later on too. If you needed to remove a board, or you're having too many problems with the lumber you've selected for the exterior stairway, then it wouldn't be a bad idea to bolt the treads off, get another piece of lumber, or plane the lumber, shape the lumber to where it'll fit this time, or it'll be tight. Cut it or plane it, whatever you would do. And because you could always, if you have a warped piece in the front, you could always move this piece to the front and then put the warped piece in the back, cut it to where it's straight again and you don't have a gap in here, and have it tight. And if it's only a 1/2 inch difference or 3/4 of an inch, you could always just add some material to the back of it to make up for it, and just screw it into the back of the tread. So again, that's probably off topic here, but there are ways to fix boards that warp and twist sometimes. If you have a board that is warped, it's flat at this end, but you come over to this end and it's sticking up 1 inch. Good luck. It's going to be easier just to replace the replace the piece of damaged wood. And I would even recommend doing that in the situation like this. I would recommend this board right here would probably need to be replaced, whichever one is cupped or bowed, I should say. And if both of the boards are bowed, then get rid of both of them and redo it. But you could see where something like this, it's untreated. There's not a sealer on it. There's no paint. You could see where something like this over time is going to get wet. It's going to absorb water. It's going to dry in the summertime. So you're going to have the wood expanding and contracting. Something like this is expected. Something like this is one of these things where you're just like, you're lucky. It's going to be more common. I mean, out of the 4 boards we're looking at here, 4 steps, all of them have a gap in it except for one. So this is obviously going to be more common. And this is where strapping them together at the very beginning when they were tight might provide you with a little more, or might provide you with a method for eliminating this problem altogether. So I've never tried it, just kind of thought about it and thought I would throw it out there. If you like it, hit the old thumbs up button and let me know. And thanks for watching. Don't forget to check out some of our other videos on YouTube. And if you can't find the videos on YouTube, make sure that you visit our website to find a complete organized list of all of the videos we've made so far.